Hello students, I am Professor Rajesh Kade, working as workshop superintendent in MIT Polytechnic College, Kothurud, Pune, continuing the same video lecture series. This is the second part from 4D printing. It is suggesting 3D scanning, in which you should understand 3D printing technologies, and the key takeaways for this particular setup is you should understand the 3D scanning technology, the functions and applications of the same. Now to start with the introduction part of 3D scanning technology, it is a scanner, it is a 3D scanner. Now you have scanner, different types of CT scan scanners are there in medical usage these days in medical in hospitals. So they are scanning your complete body, they are giving you results related to that. Any discrepancy or any error is there in body, any error is there in your body, it is known by that particular setup. It was previously we were using X-rays. These days we are using scanning. So 3D scanner is a device that analyzes a real world object or environment to collect data on its shape and its appearance, that is color. The collected data then can be used to construct high resolution accurate digital 3D models. So 3D scanning is being shown in figure. There is a complex geometry of casting V3 block, or a casting block is there, and it is being scanned by this scanner in such a way that it is creating the geometry, and by collecting the data it is creating a geometry in the respective digital tools. So it is a technique used to capture the shape of an object using a 3D scanner. The result of 3D file of the object can be saved, edited, or even 3D printed. Many different 3D scanning technologies exist to 3D scan object, environment, and people. Each 3D scanning technology comes with its own limitation, advantages, and cost. So the diagram is being shown by Seraform, Metrascan, optionally track 3D scanning and probing systems. So the image is quite clear. Here in the next slide you see that what is 3D scanning working, how it works. So there are two major categories of scanners based on the way they capture the data. That is most important. One is the white light and structured light system that will take single snapshot scans, and their scan arms and portable handheld scanners that capture multiple images continuously. Scanning results are represented using free form unstructured three-dimensional data, and the diagram is shown below. It is a triangulated mesh. This kind of mesh you can see in ANSYS software also. Then you have functions of 3D scanning. What are the different functions of 3D scanning? The purpose of 3D scanning is to collect data of a real world object or environment, to recreate design in the form of digital 3D model that is quite understood. You can understand internal structure of the same and internal geometries or complexities of that structure. It bridges a gap between physical world and digital world. That is true. And then you have what are the different types of scanners you can use in 3D scanning. So the two major categories is contact and non-contact type. So contact type and non-contact type are the two basic broad categories into which the 3D scanners are segregated. The first being the contact type. Suppose I take, so it has active time of flight, triangulation, structured light, industrial computed tomography, that is CT. Then you have passive stereoscopic, photometric, and silhouette. So these are different types of scanners, 3D scanners that are used either in either of the category, that is contact type and non-contact type. Then contact type 3D scanning, you have 3D contact scanners generally calibrated to operate on a fixed platform and often contain a probe located at the end of the articulated mechanical arm. Now this articulated mechanical arm could be a robot also, or it could be a arm specially designed for the said processes. The arm may be robotically or manually manipulated over the parts of surfaces. As the probe contact the object surface, the scanner records XYZ positions of the probe by taking positional measurements of the armature. The recorded positions from a point cloud, which can be used to calculate a 3D mesh. Some highly accurate 3D scanners called coordinate measuring machines. Now you know this stuff, you have studied that in metrology and quality control, are often used by the manufacturing industry to inspect parts for early indications of assembly problems. The non-contactive type of 3D scannings are, in non-contactive type scanning process, scanners emit some kind of radiation or light and detects this reflection frequencies or radiation passing through the object, and from there it generates the required types of data, and also the errors that may include light, ultrasound, or X-ray. Then you have functions of 3D scanning. Non-contact passive type 3D scanners are do not emit any kind of radiation themselves, but instead, depending on detecting reflected ambient radiations, most solutions of this type detect visible light because it is readily available ambient from ambient radiation. Application of 3D scannings are in the field of education, mechanical engineering, and reverse engineering also. And that is it from my side. I'll take your leave now. I'll be stopping now.